So another example you might see of discrete and continuous, it could look like, so discrete on a graph, it'd be just like random points. And then continuous would be they're connected. I'm going to underline where it says cost, Y, and dollars of X tickets. Okay, probably important. For a museum, each customer can buy a maximum of 4 tickets. First thing we need to do is find the domain. Remember, domain represents your input values. Sometimes that's your x values. In this case, it is. X values or your independent variable or your cause. So my domain, let's write out our variable. So x stands for what?
Tickets for museum.
Yep, so x is tickets. And what does y stand for? Cost in dollars. And we know that you can only buy a maximum of 4 tickets. So again, tickets, that'll be your domain. What is the minimum amount of tickets I could buy? Could I buy a negative amount of tickets? Could I buy 0 tickets?
Yes.
Yeah. Could I buy 5 tickets?
No.
No. So our tickets we could buy between which 2 numbers? 0 and 4. So I'm just kind of writing that out to explain it to myself. So if we're buying between 0 and 4, X is tickets. So my domain, could I buy 1.2 tickets? Does that make sense? So I can buy 0 tickets. What's the next number? 1. What's next? 3, 4. Because you can't buy like half of a ticket, right? You can only buy whole numbers of tickets. And so look back at the top. If it's only certain numbers, then is it discrete or continuous? This is discrete. Isaiah, how do you know it's discrete? So it's only, you can only have certain numbers because you can only have, we'll say whole numbers of tickets. You can't have 1.3 tickets. You can't have 3.5 tickets. You're only going to buy 0 tickets, 1 ticket, 2, 3, or 4. And so when we graph it, it's just going to be points on a graph. It's not going to be connected. So then it says graph using the domain. So what we're going to do to graph it is we're going to take our equation, which is y equals 15.95x, and we are going to plug in x values. Anybody want to tell me what x values do you think we're going to use? Yeah, so the x values, the only ones that we're actually allowed to use are these. And so we're going to take those 5 values and we're going to plug them into our equation to figure out what the cost would be. So we did this the other day when we did independent and dependent, where you replace x with the number you're given. So replace x with first 0. So if I multiply 15.95 and 0, what do I get? 0. And then you do that for each of the other ones. So now we're multiplying by 1. And we get?
15.95.
If you feel like you are good and you know what you're doing, you can move on without me. So we're just multiplying by 15.95 because each ticket costs $15.95. Plug in 2. Could someone give me the cost for 2 tickets? $31.90. Okay. What about for 3 tickets? Okay. And then we'll plug in 4. What do you got for 4? 63? Okay. Do you guys agree with those values? So 0 tickets cost $0. 1 ticket costs $15.95. 2, $31.90, etc., etc. But we stop at 4 because it says you can get a maximum of 4. When you're graphing these types of things, so now we're going to use our table to graph. We're just going to plot the points. But before we do that, we need to label what each axis means, and we need to go ahead and scale it. So most of the ones I'll give you in this unit will be scaled for you, but today it's not. So we're going to label it. What does X represent again? Tickets. So on my X-axis, I'm going to label, so we'll call this is X. And this is number of tickets. What does Y stand for? Cost. So my Y-axis is the vertical one, and so I say cost in dollars, right? Or you could put dollars like right out the words. Now we need to label it, so we know that the origin is 0. We go by ones, so 1, 2, 3, 4, 5, 6, 7. We want to try and spread it out as much as we can, but that's as small as we go. And then on the y-axis, we have to go all the way up to 63. So what could I make my y-axis go by? 15, so it'd be 15, 30, 45, 60. That would get there real quick. Could you spread it out a little bit more? So can we go by a smaller number? So let's go by tens. So 10, 20, 30, 40, 50, 60, and then the last one will be 70, so just slightly above where we're going to graph. We graph each pair of numbers as an ordered pair on the graph. So we take 0, 0, and we plot it on the graph. I'm going to do that in blue. So 0, 0 will be right here at the bottom. Next is 1 and 15.95. So you're going to have to kind of approximate. I know 15 goes in between 10 and 20, but it's 15.95. So it goes up a little past halfway between those numbers. Next is, I don't even know, 31.90. So that's about at 32. So that'd be just a little bit past 30. And keep going from there. So at 3, it's 47.85. So that's just a little bit below 50. And then at 4, it's 63.80. So that is a little bit past, a little bit below halfway between 60 and 70. Do we connect these 5 points? No, because we can't have 1.5 tickets or 3.1 tickets. So do not connect discrete. Because it can only be the whole numbers. It can't be everything in between, like the decimals and stuff. Continuous. Oh. Which one are you back? Is it going to be linear? So I'll say linear because it's adding 130. every time we eat a bar. And so, like Kieran said, that's a constant rate of change. Here's a problem. Do we have x in this problem?
No, it doesn't tell us how many.
No. We have C for calories and B for bars. So in order to figure out which one, so we can write that down. C is the calories. B is the bars. We got to figure out which one depends on the other. So we need to figure out the independent variable. That way we know which one is like the x in this problem. So which one of these, calories or bars, which one is the cause? So the independent variable is bars, the dv is calories, and so that means that my domain is going to be bars. So we need to figure out the domain. Always start with like, what's the lowest amount that you could have? What's the lowest amount of bars that you could eat? 0. Okay. And then kind of ask yourself, could we eat 0.5 of a bar, like half of a bar?
Yes.
Could we eat 1 bar?
Yes.
Could we eat 1 1/4 of a bar?
Yeah.
Okay, so is this going to be discrete or continuous?
Continuous.
Continuous, because you can have 1 bar, 2 bar, 3 bar, 4 bars, but you can also have everything in between. So this is continuous. Because you can eat, we say like any number or all real numbers of bars. So anything above 0 you could have, right? Any real number above 0, 1.54, you could eat that much of a bar. So my domain, you guys said, starts at 0. So my bars would have to be, we know for sure, greater than 0. Where does it stop?
6. I don't know.
Does it have a stopping point? Are we limited? No. So we could eat anything greater than or equal to 0 bars.
We just go to run out of room.
So we have to still pick some values for x, and I really shouldn't say this is x, right? We should change it to B and C. So B for bars and C for calories. Let's start out with 0 and then just use whole numbers, but we need to remember that when we graph it, it's continuous. But we'll use this to guide our graph. So we don't have to write an equation. We can just think about it with me. At 0 bars, how many calories? 0. If you've eaten 1 bar, how many calories? 130. 2. Add another 130, right? 260, because it's a constant rate of change, so we're adding 130 every time. If you add 130 again, yep. And you add 130 one more time.
420.
520.
Yeah.
So on your graph, could you please, let's see, this is going to be B for bars, and the y-axis is going to be C. So independent goes on the horizontal, dependent goes on the vertical. So we've got number of bars and number of calories. Zero goes at the origin. Let's just make our bars go by 1. So we're going to label each square 1. So we'll get up to 7. And Carson, Milbrandt, what do you think I should label my C-axis or my Y-axis? Or how do I scale it? 100. Right, because the highest number we go up to is 520. And so we have to at least get up to like 600. So we'll go by 100s. That'll work. And go ahead and plot your points. So we have at 0 bars, we are at 0 calories. At 1 bar, we are at 130. So that is a little bit lower than halfway between 100 and 200. At 2, we're at 260. So a little bit above halfway. 3 is at 390, a little bit below 400, and 5 is at 520. No, 4 is at 520. So this is continuous because we could have half of a bar or a quarter of a bar, and so we connect the dots. Pardon my not straight line here. Let's get an actual straight line, yeah? I don't know how to do it. I'll do it later. So straight line. And we have an arrow at the end of it. This is called a ray. Because you could keep eating, you could have like 100 bars if you really want to. It doesn't give us a limit. So make an arrow because it's continuous and because there's not a limit.
Is that it?
Yeah, that's it.